So guys, now we're going to talk about the center of mass. Now, center of mass is basically defined as the point where the weight of the object may be considered to act or where the weight is considered to act, okay? So in these regular shaped objects, the weight is always pointing downwards as we agreed, and it points from the intersection of the diagonals, okay? A square, a rectangle, or a triangle, circle, the intersection of the diagonals is where the weight is to be acting. Now, what if you have a regular beam like this? Okay, in this regular beam, if it's got a length L, okay, uniform, regular, that's what we say. If it's got a length L, so the weight is concentrated from L over 2. That's where the weight is acting basically in the middle. So that's where the weight acts. So, for example, if you got the L is 10 centimeters, 10 meter, whatever, the weight is acting at 5 meters from that point. This is required to know. Keep that in mind. The weight is going to be acting in the center, okay? So that's the idea of center of mass. Now there's another experiment that you could talk how to locate the center of mass of an irregular shape. These were regular shaped. For irregular shape like this one, you basically hang it from different points and you just draw a line, and the intersection of these lines is where the center of mass is, okay? Now we're going to talk about stability. Stability is very important. For an object to be stable, you need the object to have a wide base and a low center of mass. So where basically the center of mass is low and the base should be wide. So for those two cars, as you can see, the red one is a larger base, and the center of mass is lower than this one, this car. So that makes the red car more stable than the green car. Okay, excellent. Now we move to the idea of toppling, which introduces us to the idea of turning effect. Okay, so if you look at those three cars, the first one, the blue car, is basically trying to rotate about this point. This point is where the object is rotating around itself. We call it the pivot. Okay, we call it the pivot. Now, this car, for example, is going on a turn and somehow it traces, the body is raised, but the weight brings it back because this is the pivot and this is the weight. This is like a perpendicular distance between the pivot and the weight. So this causes a turning effect to make it go back to its original position. Okay? If you look at this one, the center of mass, you can assume that is exactly passing on the pivot. So basically, the turning effect is 0. So the car stays stable, as you can see. It doesn't topple or anything. It just drives like this, like the brothers of Saudi always do. So if you can look at this one, the weight is outside of the base and it's causing a turning effect in this direction. So this car is not stable and it's basically going to topple. Okay, so this introduces us to the idea of turning effect. Turning effect is equal to the force multiplied by the distance perpendicular to the force. As you could see, we did this here and we did this in this part. When the distance was 0, the turning effect was 0, so the car didn't turn or anything. Okay, thank you for listening.